So this video is going to help you review section 6.1. We're going to start with how to solve an initial value problem. So if you look at an initial value problem, we'll usually have the derivative given with an initial point, and your job is to find the actual y function. And the only reason we have the initial point is if you don't have that, the answer is going to be an infinite amount of solutions. So to start off, we have dy dx is equal to 2e to the x minus cosine of x. And so since we've already done 6.4, I am going to use the proper notation, which would be to separate the variables by multiplying by dx. I'm going to integrate both sides, and we know the integral of dy is y. The integral of 2e to the x is itself 2e to the x. The integral of negative cosine would be positive sine of x, and then plus c, and then we're going to use our initial value in the problem. So y, some of you are confused, that is your x value and that is your y value. Your x is in the inside of the parentheses. 3 is equal to 2e to the 0 plus sine of 0 plus c. And so we have that 3 is equal to 2 plus the sine of 0 would be a y value of 0 plus c, therefore c equals 1. The actual answer to the question would then be the function y is equal to 2e to the x plus sine of x plus 1. Moving on, we're going to look at another initial value problem, but this, if you'll notice, starts with the second derivative. So when I do the problem, I'm actually going to be able to find the first derivative. I'm going to multiply by dx squared. I'm going to take the integral, and this will give me dy dx. The first derivative is equal to 2x minus 3x squared plus c. You have to have the plus c. I'm actually going to use this initial value to solve for my c. So my y primed of 0 is equal to 4. So 4 is the y primed, 0 is my x, and then plus c. 4 is equal to c. Therefore, my derivative function is now 2x minus 3x squared plus 4. So now we're back to the type of problem I just did. I'm going to separate. I'm going to multiply that whole thing by dx so that I can integrate. The integral of dy is y. The integral of 2x is x squared. The integral of the next term is negative x cubed. The antiderivative of 4 is 4x. And then don't forget your plus c. And now I use my other initial value. I'm going to substitute in my 1 for y, my 0 for x, which you'll notice gives you an easy c value of 1. So my original y function is x squared minus x cubed plus 4x plus 1, and we're going to hope I didn't make any mistakes in the calculations. Let me know if I did. So this was similar to the problem you had on your test, and in this case we are asked to sketch a slope field, which most of you did not have a problem with. So I'm actually not going to spend too much time on the slope field. We are going to be substituting in all the x and y values into this differential equation. So if y is equal to 0, then the slope is 0. So I'm going to start with those. If x is equal to 0, then the slope is also 0. So all of those are my 0 slopes. And then I can do whatever's left over. So if my x is negative 1 and my y is 1, then I get positive 1. If my x is negative 1 and my y is 2, that'd be positive 4. If my x is 1, my y is 1, I get negative 1. If my x is 1 and my y is 2, I get negative 4. And then at 2, if my x is 2 and my y is 1, then I get negative 2. A little bit steeper, I guess. And if x is 2 and y is 2, I get 4 times 2 is negative 8, so it should be the steepest. Write an equation for the line tangent to the graph at x equal to -1. Well, at the beginning, it said that f of -1 is equal to 2. So I have my point. The other thing I need for a tangent line would be the slope. So really, I need dy dx at the point -1 comma 2, which would be found by using the original differential equation. So I'll squeeze that in here. -1 times 2 squared all over 2. So I get positive 4 on top divided by 2, which makes a slope of 2. So my tangent line equation would be y minus the y of the point equals the slope times x minus the x of the point. So that turns into a +1. The other problem that was at the end, part C, asked for you to find when the derivative is positive, negative, 0, or undefined. 0 is always the easiest one. The dy dx equals 0 we found when x is 0 or when y is equal to 0. You should notice that there's no way to get undefined. And then the harder of the two questions would be positive or negative. So we're going to look at the derivative, and we're essentially going to analyze it like we're making a sign chart. You should notice that since y is squared, it won't matter what y is. That part of the term is always going to be positive. So really, you only have to look at negative x over 2. Well, negative x over 2 equals 0 when x is equal to 0. I'm going to do a nice little sign chart. When x is equal to 0, dy dx is 0. We already knew that. But when I substitute in a positive number for x, the entire differential becomes negative because I have negative x over 2. So negative times positive 1 over 2 would make the slope negative on this side. On the left side of 0, if I substitute in negative 2, I would turn the numerator to be positive, therefore the term would become positive. Now, that gives you part of the answer. You'll notice there was a little bit more. So the positive dy dx's happen when x is less than 0, but remember, and y cannot equal 0, because if y equals 0, the slope becomes 0. For the second part, you get negative slopes when x is greater than 0, and you have to say when y is not equal to 0. Believe that should be everything that I wanted to do for slope fields in section 6.1.